Hello, this is Carl Jimenez, and my partner is Eric Soon. This is our deadlock project for CS162. Each process holds these four fields, the first being an array list of initial resources held by the process, named resources held. The second is an array list of resources it will need, named resources needed. The third is a static array list of available resources, named resources available. And the last is an int ID number for the process. Next is the constructor that simply instantiates the array lists. Now on to the methods. The first method being establish held with argument amount. This method will add the amount to the resources held array list to establish the amount of that resource. Note that we don't specify a resource to add to, because when we establish the process, we will simply use add to put each resource and its amount in the array list. The next method is establish needed with argument amount. This method is the same as establish held, but this time it will add the amount to the resources needed array list. The next method is a Boolean method called doable. This method will return a boolean named has everything needed, which will only be true when the amount of resources needed is less than or equal to the amount of available resources. The next method is called giveResource with argument int type and int amount. Given the type or the resource index, this method will add the amount to the same index in resources held, while reducing the amount of the same index in both resources needed and resources available. Next is the array list method named release resources. This method returns an array list named safeKeep, which will be a copy of the original resources held of the process. It also empties each resource of resources held. Then add the amount that was emptied to both resources available and resources needed. We made it return safeKeep so that when deadlocks happen and the released resources are not enough for the other process to run, we will simply use this array list to return this process to its original state. Last is the setID method with argument I. This method simply sets the ID of the process to the given argument. Now to move on to our main class named deadlocks. The first part of our main method is the initialization phase. Firstly, the number of cases, processes, and resource types are stored. Then a for loop is made based on the number of cases to be done. Next, the array list process array is initialized, and the static array list resources available is given the available resources. Process array is then given processes based on the number given, and then it will give each process the amount of each resource that it will hold. Lastly, it will give the needed amount of each resource for each process. Now the next part is the solving phase. Basically in our code, in order to prevent having deadlocks, our program will make the processes in deadlock release their resources one at a time until the current process in deadlock can be run. If it doesn't, it will return the resources of that process and move on to the next process in deadlock. The way we did this is first, we used two booleans. smoothFlow, which tells when the program encountered a deadlock, and did something, which is an indicator of whether or not the current process was worked on. Then, we used a while loop to have it continue until all the processes in the process array are done. Then have an inner for loop to check each process in the process array for what can be done. In our code, there are three major if segments. The first happens only when deadlocks have to be handled, and processes need their resources released for others to run. The second is the one that does the processes that according to their doable method are able to be finished. The third and last one is the deadlock detector that will say when the first if segment has to be done on the next run-through. The ArrayList safeKeep stats in this case uses the safeKeep from the release resources method so that we can break out of the loop if the current process can now be done, and proceed to do that process. Or if not, it will return the resources of that process and move on to the next. So this is how this whole part will run. First, it will check each process in the process array for any doable processes. Then after each completed process, it will remove that process from the array list and release its resources. The reason for this is that when the program has finished its run-through of the array list, this makes it so that only the unfinished processes remain when it loops back to finish the rest. It will do several loops in order to finish as many processes as it can until it either empties the array list or encounters a deadlock. When the deadlock happens, it will go to the first if segment and fix the deadlock there, using the solution we explained earlier. Now to show you the output of our code. Given the input above, our program will yield the results shown below it. Process 1 and Process 2 did not have the resources they needed yet, so Process 3 was done first, then Process 4 was the next. Then our program looped back to 1, but it still did not have the resources to run, so Process 2 was completed, then finally 1 was done after. In this example, no deadlock occurred. In this next example, however, you can see a lack of resources for Process 1 and Process 2. Process 3 will be done since it has the resources to do so. But as you can see, the program will indicate that a deadlock has occurred. So our program released the resources of Process 2 since Process 1 requested first, and that it was the resources Process 1 needed in order to run. Then finally Process 2 was done. And that's it for our code. Thank you for your time.